Thanks, Christopher. Cool. Well, it's great to be here. Paris is an amazing city. Hope all those traveling from out of town are enjoying it as much as I am. As Christopher said, animation is kind of like everyone's favorite bike shed. There's a billion different ways to do it, but a lot of times we end up kind of implementing the same sort of things. And so we took it as part of the goal of React Native to try and build a really great animation API that's kind of optimized for some of the things that we can do in React Native, but also is pretty general that might also apply to like standard web apps and websites. So I figured since I was giving a talk about animations, I would use the opposite for my slides. So we just have Markdown here. So fluid interactions. Today in modern web apps, people expect smooth, delightful experiences, right? They want all those nice little interactions and stuff to happen when they click things. But the problem is a lot of these complex interactions are hard. There's lots of weird edge cases. It's hard to get 60 frame per second performance. And so we do a lot of things to try and bang our head against the wall and make these really great experiences and fix a lot of bugs. It also tends to be the case that there's a lot of common patterns that we can optimize, both from the performance side and making it that like 60 frame per second experience, but also from the developer side and making these patterns much easier for people to implement and handle some of the heavy lifting that tends to cause bugs, like handling references and all this kind of stuff. So in order to do fluid interactions, we're going to do declarative interactions. And so the idea is that we're going to wire up inputs, such as like touch events, things like that, to outputs, which are typically props on your React components. And then we're going to pass them through transforms of various types. So this could be spring physics, easing functions, or like interpolation systems, things like that. And then we're going to use arbitrary code to actually define or update that declarative configuration. And so this is just like how your render function and your React component is just running arbitrary JavaScript to do whatever you want to declare the final description of what you actually want to present, right? One of the cool things about this approach is that this configuration can be serialized. So then we can export it and run it in native and core animation, or we can run it in a separate JavaScript context that's running synchronously on the main thread. There's a lot of opportunities to do some pretty sweet optimizations in the back end. And of course, we wanted to make sure that there was no refs or other lifecycle stuff that you have to worry about because it tends to cause bugs and is just kind of tedious to deal with. And so if it's handled automatically by the framework, it fixes a lot of problems for people. So I'm going to be talking about Animated, which is going to be a library for React Native. Soon to be released, and soon here is days, not weeks or months, so you'll be able to play with it really soon. And right now it's 100% JS implementation, which makes it cross-platform, and we'll be able to use it pretty much out of the box on our Android React Native systems. And if we have the time, it shouldn't be too much trouble to make it work on the web as well. Maybe with some help from the community to make that happen. But there's a lot of really cool per-platform native optimizations that we have planned that'll be able to make your same code with the same API just start running faster because it'll start offloading some of the operations onto the native system. And so for this talk in particular, I'm going to be focusing entirely on usage examples, just kind of walking through a bunch of different types of animations and interactions that you've seen in a lot of apps that kind of give you that like, ooh, that's a nice little thing, and not really talking about the implementation at all. So the Gratuitous animation demo app. So it starts off right here with just basic like grid layout using Flex Wrap. We have I'm going to start off with no animations here. So like if I press, do like a long press, I can like pick this one up and then put it over here. And you can see the Flex Wrap just kind of like reorders them, right? So if I want to take like E0, swap it with E1, they'll just switch, right? And then, and then you can open these and they'll just like switch to like another view, like a modal view, right? Great. So let's jump into the code here. So the first thing we're going to do is we're going to add like actual tracking with like a pan gesture, right? So a lot of you are probably familiar with like the pan responder system that you can use with React on the web or React Native. So we're going to use that. So first step, we're going to take, we're going to uncomment this guy, and so, oops, sorry. Right there. And so we have a pan element in our state, and it's going to be this new animated value xy. So this is basically a vector, which is a common 2D applications. You have a 2D vector, reduces a lot of boilerplate for us. So the next step, we're going to, in our pan responder system, we're going to add a pan responder move. But it's not going to be a function. There's no actual like JavaScript code that's going to run in a callback. We're just declaring that the gesture state dx field is going to map to our pan x, and dy is going to map to pan y. And you can see this is for the second argument that's passed to the function, and the first argument is the native event, and we don't really want to process that because we want to use the massage data from the pan responder, which is the second argument here. Cool. So the next thing we want to do is, now that we have this linked pan variable, we want to actually do something with it. So we're going to take our drag style, which is applied to the object once we've picked it up and we're moving it around. We're going to position absolute it, and then we're going to take the pan and extract, basically convert it into layout. So it's an XY vector thingy. We're going to turn it into like top left, right? So next thing we're going to do is when the responder gives us the grant, we're going to run whatever code we want. This is just JavaScript. And we're basically going to reset the position and then set an offset, which is equal to the position in the grid that we picked it up from, right? So it's really simple. Basically just says like, okay, this is the state. And then it can like hand off to the rest of the system to actually process the continuous events. Cool. So then one other thing we want to do is we can add a listener to this pan event, which is going to run arbitrary JavaScript code. But the idea here is that it's running asynchronously, and potentially there's some lag, or maybe it's not going to run at a full 60 frames per second. And so you can execute JavaScript code that's going to do like large state changes, right? And so say it's running at like 10 frames a second or something, you're basically just going to run this on move function, which is going to check to see like, oh, did the user move their circle far enough such that it's in a new position and I want to change the layout, right? And so what this will let us do is actually update the layout live while you're dragging it around before you drop it down. Cool. So let's refresh our app. We grab this and it tracks. And when we move it here, the layout updates, right? Pretty cool. That was all the code necessary to make that happen. Okay. So next thing, that felt a little bland, right? It was kind of like clunking around. So we can add a little pop-out spring animation to give the user some sense that once the long press activated, that they're dragging it around. So first thing we're going to do is the same thing. We're going to make our value that's going to be animated. And so this is just one dimensional. We're just going to like do like a scale. Then we want to, in our long press handler, we're just going to add a simple spring. And so this is going to take our pop variable that we just made, and it's going to animate it to the value 1, right? So it's going to go from 0 to 1, and then we have some config that specifies the like tension and friction of the spring to get the kind of bounciness that we want. And then, of course, when we release, we want to go back to where it was. So we're going to animate the pop variable back to 0, and we're going to use the same spring configuration so that it's symmetrical. Cool. So now that we have that value animating, we need to actually hook it up to the style. And so our animated style here, we're going to have, oops. We're going to have an opacity, so we want to, on the shadow, so we want the shadow to kind of appear like as it animates out. And we're going to have a transform, which is going to do an interpolation on our pop value for the scale aspect. And we're going to go from 0 to 1, which is what we're animating to, and map that to 1 so that it's just displaying normally with a scale of 1 in the beginning, and then go to 1.3 to like kind of expand it a little bit. Right? So reload this, and then I do tap and hold, and you get a nice like bounce animation. Right? And then I can still drag it around and then drop it. Cool so far? All right. So now that grid reordering is kind of clunky, right? It's just like snapping around. For those of you who've used React Native, you might be familiar with the layout animation system, which has been in the repo for a while. What I'm showing here is basically that it can kind of interoperate with the system. So pretty much all we need to do is just declare layout animation ease in, ease out. And what this is going to do is say for the next layout transaction, after I process all of my React updates, all the stuff that's going on, animate everything with this particular curve, which is the default ease in, ease out curve. And we're going to do this whenever the onMove callback decides that the keys have changed, like reordered themselves. Right? And then I also want to animate on release, so that when I let go of the thing, it animates into place in the new spot. Right? So I just add those 2 lines of code. And now if I pick it up, drag it around, we get nice little animations. You can see it's, because it's computing the full flex wrap, things can reorder all over the place. And animations can be like interrupted, and everything works fluidly. Cool. Thanks. Cool. So the last part of this part of the demo is this opening animation. That's pretty terrible, right? Yeah. So how do we animate that? So up to the top here. Okay. So we have this open val, which is already animating the same kind of way you saw before, where it's just adding a spring to it. And we want to do a whole bunch of styling on these guys, right? So basically what this is going to do is it's going to map the left, top, width, height to kind of where it started, like the rest layout, and like the size of the circle, to like left and right, like going like to the bounds of the system, and the width going to the width of the container and the height of the container. And then we want to get rid of the margin that we had in there, and then we want the border radius to kind of go from the circle to like a bigger border radius, so it kind of expands into a circle and then goes into like little sharp corners. And you can see the interpolate function here can take any number of ranges that map to different parts of the output range here. So you can do pretty interesting things with a pretty nice simple API. So then here we're going to actually add the spring. So before we were just setting state directly. Now we're going to add a spring, and then the spring start function has a callback, and it'll set the state once the spring is done running its animation. And again, we're taking the open value, going to 0 when it deactivates. And then instead of just setting the value directly to 1 to open it, we're going to do an animated spring, set the value to 1 there. Okay. And so now when I tap one of these guys, you get that nice like opening animation. But you can see that all of the Flexbox layout inside it is also animating along, right? Cool. And I'll get back to that in a little bit. Yeah, so that's kind of the live coding stuff. We'll walk through the rest of the examples here. So this is the example set. This is kind of just a container of a bunch of stuff. So you can see we have bobbles, change, scrolling, tilt, that are all like subcomponents. So this all composes nicely. One thing you might have noticed is that the color of the header also was animating during the open transition. So you can see this is purple, goes to a green. This one's like kind of magenta, goes to pink, which is almost the same color. Everything's random here, so yeah, there you go, like a green to red. And you can see the way that's working is that we have this random color generator, which produces a bunch of numbers and then joins them together into an RGB string. And then with our interpolate on this set component, we're going to take the open value that was passed in from the parent, so you can actually link these animated values together, pass them around like normal props, and then the output range is actually just going to be these two color strings. And the system is going to strip out the like non-numeric parts of those components, and then update the values, and then regenerate them. So you can also do like degrees versus radians to get different units and things like that, and they'll just animate transparently through the interpolation system. Right, forgot to move my slide. Cool, and then you can see down here in the render function, like we're just composing all of our other little examples here. Cool, so the one thing we have here is a cool dismissal gesture. So you can see in the component will mount, we're going to do the same thing where we have like an animated dismiss, and then we're going to have a responder on grant. We're basically going to say to do a spring, open this guy, and then on move, we're going to track the value here. And then on release, we're either going to delegate to the parent to dismiss us, which is if we drag it down far enough, or we're going to do a spring that animates it back open, right? So what this looks like is basically I can drag here, and it'll actually update that same value getting passed in from the parent and animate like all of the things that are linked to that. And then when I dismiss it, it'll drag down. And the image cache is failing. Cool. And then if I don't take it down far enough, it'll kind of bounce open a little bit. Cool. All right, so let's look at some of these examples in here. So the first one is this little tilting component. So you might have noticed that as soon as it mounts, it starts a little kind of like burns, like slowly pan across the image to make it look a little dynamic. But we can also pan it side to side here. And you can see there's some opacity actions kind of fading away. But there's also some parallax, so the image isn't moving as much as the container, right? And then if I swipe it all the way, it'll kind of reset itself, restart that animation, fade in. And this is all done with the same declarative system. So you can see we declare the state, so there's a pan X, opacity, and then the burns values. We have a pan responder that on grant is basically going to map the opacity to the pan X value. So this is actually linking the two animated values. And so whenever the pan changes, opacity will change, but then we're also going to compose it with the interpolation. So the pan is going from negative 300 pixels to 300 pixels, depending on how you drag it around, but we want the opacity to map from just 0 to 1. And so you can see that happening there. And then if we just set the duration 0 on the timing animation, it's basically just going to update immediately. And so it's just rigidly linking these two systems together. And then the move is the same thing. We map dx to pan x. And then on release, we do a little bit of math to figure out if we moved it far enough and to the left or the right. And then we just do a spring animation where we maintain the velocity. So if you release with a lot of velocity, it'll kind of carry that through the spring physics. And then we have to handle the, like, once it's all the way off the screen. And so that has another feature, Adlistener. And so this is similar to what we were using before for the onMove. And it basically says, asynchronously track this thing and run whatever JavaScript code you want, but it's probably out of band or low frequency depending on what other work needs to be done, like high pri work. And if the value goes past 400, then we're just going to do this kind of reset animation and restart the burn zoom and stuff like that. Cool. So the tilting photo. So for the bobbles, that's this little guy here. So this is the kind of thing you might have seen in the Facebook Home app for Android. So they bounce out, and then this is tracking, and then I can kind of like move them around, and the bobbles will like follow this and stick here and there. And so the way this works is that we define the static positions, which are always the same, depending on like what radius and like how many bobbles we want. And then we do this simple thing where we just take all those spots and we make an animated vector for each one of them. And then in the pan listener, this is the same kind of like low frequency asynchronous thing that's going to listen to the state. And it's going to see, did you move it such that I should select a different bobble? And that's basically going to reconfigure it so that a different bobble is stuck to the selector and animates the previous one back to its rest position, right? And so that's done again with like a spring, just going from the selected bobble to its rest spot, or it's going to actually link the newly selected bobble to the leader, which is the first bobble or the selector, right? And then it just sets the selected one as the new one, and then the next time that fires, if it changes, it'll update the animation configuration. And then on release, all we're going to do is just send all of the bobbles to 0, right? So they just like shoot back down to the beginning. And then the opposite on grant, we go through all the bobble spots and we just do a simple spring where each value or each bobble goes to its spot, right? And that's pretty much all the code to configure this arrangement, these physics. And then the move is just mapping dx to the first bobble x and the first bobble y, right? And then this is another way that we can hook in the bobble pan listener. So instead of listening to the actual value, which may have other animations being applied to it, we can just listen directly to the event, again, in kind of this like async manner. Yep, and then just really simply applying the state. So if the handler is, if the handler is the first one, then we add, or if the bobble is the first one, we add the pan handlers. Otherwise, there's no gesture handling. And then for each one of them, we just take the bobbles and then we convert the XY vector into a translate transform, which is like translate X equals this one and translate Y equals that one. And then those just get linked together. And that's how you build a bobble. So chained is kind of a classic, like, everyone's seen like chat heads and it's like really neat, but you're not really sure like how to use it. And what we have here is basically a bunch of stickers and they're linked together with springs, right? So you can like dance them around and they follow each other. And then when we release, we want to do a little decay kind of thing, right? And so there's like a decay animation, then we can like grab it, pick it up, and then if we don't do anything, then it kind of zips back to the beginning so that we can keep playing with it. And so the way this works is we create our lead sticker, and then for the 4 other ones, we make an animated vector for it, and then we create a spring animation that's going from that new sticker to the previous sticker, right? And so that's basically just going to link the two with a spring that has the configuration that we want, right? Which is a little bit softer spring, so it's kind of a more gentle, like tracking animation. And then we just push that new sticker into our list of stickers so that we have them all. And that's pretty much all of that interaction between the springs. Then we have similar things. So on release, what we're going to do is take the first sticker and just give it a decay. And it's just going to take the velocity of the gesture when we released and just decay at some rate. And then once that stops, then we're going to run this spring animation to zip it back to the beginning, but only if the animation actually ran to completion. If it was interrupted, then this callback will get fired with finished equals false, and that means that we grabbed it while it was still in the middle of the decay animation, right? And then again, all this does is just resets our offset and zips all the stickers back to the 0 point, or sticks just the leader actually back to the 0 point, and then all the other ones follow. And then on the pan responder grant, what we're going to do is, because that decay animation might be happening, or it might not, the system's robust to that, you take the first sticker and you say stop animation, and then that'll give you a callback once, because it might be communicating with the native system, which is the only place where it actually knows the value. And once it gets that value after stopping the animation, it'll pass it back to your JavaScript function. You can do whatever kind of state transition you want. And so what we're going to do here is we're going to set the offset to this value so that when we grab it, the new relative position of the gesture is offset by the point at which you grabbed it in the grant. And then we're going to just like zero everything out. And then again, a simple, like the move is just going to map to the first sticker X and Y. And that's pretty much all the code there. Again, we attach the handlers only to the first one, and then the transform is the get translate transform right there. And so then you can play with your things. But what's also really cool is all of these animations are attached to their relative components, so they get unmounted and stopped and all that stuff correctly. But they'll also just keep running independently. So if I run this, like that animation will like fly in. Or I can, do bobbles while this is animating. Like all this kind of stuff like works together really nicely. So I just have a couple minutes. I didn't think I'd be able to get to this demo, but I'll go through it quickly. So scrolling, one of the things you might have seen in apps is like a nice Nux thing where there's like 4 things you need to learn about the app, and you kind of scroll from one to the other, and it might do a little animation transition thing between it, maybe with some cute stickers to like keep you excited about using your new app. And so what we have here is the same kind of thing. So this is just a normal scroll view, and we've linked the scroll events to some transforms. And so as we move that down, this little guy pops up. And then as we go to the next one, he scales up, right? And so this kind of demonstrates some of the multi-range stuff. So here we're attaching to a different type of event. This is an on-scroll instead of a panhandler. And so you can see we basically have this nested declarative configuration that's going to take the native event and extract the content offset from it, and then extract the X position from there, and then that's going to link it to our scroll X value. And then we basically just take that and do a bunch of transforms. So we have our bunny image, which is this guy here. And we're going to do a translate X, which is going to do some cool interpolation. So from the starting point to the first screen, we don't want to change the X position at all. So those are both 0. And then when we go from the second screen to the third screen, we want to move it by 1/3 of the width of the screen. And then for translate Y, we want to move, in the first thing, we would just want to move it up. So that's what gives us this only vertical motion, not the horizontal. And then we want to do a little bit of adjustment as it comes across here, right? And then we also want to do the scale. So again, we start off 50% scaled for the first 2 screens, and then we go up to a 2 scale at the end of for the final panel. So when it's animating here, it scales, but here there's no scale. So this interpolation function is actually quite powerful, and it has like a couple options. So you can do like a clamp extrapolation. So if you go past the limits, it'll just you'll just hit the edge, or you can do an extend, which is the default, and it'll just kind of, if you say like map 1 to 1, and then you go to 100, it'll just go to 100 on the output as well. Just map that through. You can also set easing functions, so your interpolation can run through like an ease in, ease out, and all sorts of interesting stuff there. Yeah, so that's the new React Native animated library. It's going to be landing soon in master. We might do it in pieces, so kind of the initial functionality might land earlier, and then we'll get all the vectors and other stuff landing after that. We use the first half of the animation system already in our production apps, so we feel reasonably confident that it's pretty stable, but the new stuff hasn't quite been used yet, so it might take a little longer to nail down all the bugs. Yeah, questions? I think your hand was up first.
Why are you using animated image instead of image?
So this is something we actually debated early in the project. So animated basically exposes a few things that are wrapped in this function that basically takes any component and turns it into an animated one. We thought about baking that into React itself so that any React component could just be, or any native React component could be animated like this. But we decided to keep things kind of separate and more composable. But what it's doing behind the scenes is it's actually searching through all of your properties to see if any of them are animated, and then doing its own direct updates through to the native system so that it doesn't have to call set state and re-render things to fast path it. Yeah. There's another question over here.
You mentioned this being live right now in Facebook apps. Is it in the Android ads app as well to do cross-platform?
Yes, I believe it is in the Android and iOS apps now. I think they've both been released with this library in them. But it's only using the output half, not the input. So the animated event, I don't think, has gone out in any production apps yet. Question?
How do you manage having, like, so in there, there's a lot of animation, like Interpolation, that kind of makes it difficult to see what components are actually doing statically. How do you manage that in a web app?
Well, I mean, you can still, so the question was, you know, there's a lot of like configuration that's kind of static, like up at the top, or maybe for one of these other ones. And how do you separate that from the actual component itself? And I mean, the nice thing is that it is very composable, right? So if you end up having like a big, messy animation thing, you should be able to actually break down into subcomponents just like you can for complex views. And then you can actually, like if they do end up linking to the same value, you can still pass those values through as props, just like you would with like data from a Flux store or whatever. So it ends up composing reasonably nicely. Okay, I think I'm out of time, but one last question.
Do you have, I mean, I know you talked about this being cross-platform and being built in a way that you might be able to use it in the web in the future. Do you have any, like, looking at this as a web developer, it seems to me that we wouldn't be able to perhaps use animation in this way and get good performance with the current performance levels we have. Would you have to make use of the library in a completely different way and be much more conservative when applying animation on the web, or do you think that the library will be able to take care of that for you and do some very smart platforms to avoid doing expensive things, basically, like?
Yeah, so the question is, you know, I said that like we could probably bring this to the web, but it seems like there's a lot going on there. Maybe it won't actually work, or the performance will be like too hard to achieve. Obviously, I mean, with any like animation system, you're going to hit limits at some point, right? So if I like increase the number of stickers here, 10x it to 40, you can see it's, oh, whoops. Oh, yeah, I don't have enough images for all 40, sorry. Yeah, but anyways, you can see it actually is computing the animation for all of those points, and it's still kind of smooth. But you will hit a limit, right? If you do enough of these things, like, you know, whatever system you have will break. And so you have to think of that when you're designing and make it within the constraints. But I do think we can actually get pretty close parity on web. And the nice thing about this API, we hope, is that there's a nice clean abstraction layer, so we can kind of do whatever is necessary behind the scenes to get that performance and make it work. So hopefully we can do that. Yeah. All right. All right, I think I'm out of time, so.